Okay. So they put this magic string as a way to identify that the following data is compressed using this algorithm. If you looking at any binary stream, you find these 2 bytes, you will probably are having some compressed information with these algorithms. And the last byte is a special byte that is reserved, and it changes whether the algorithm is the LHC, in that case, is the compression level, and in the other case, if it's the other algorithm, is the it's something that is also really tied to the way that the information is compressed, but it's the maximum number of bits per code. So in the following slides, when we start looking at the details of the 5 formats, I will mention the compression header, and I will be talking about these 8 bytes. Just to have some context and not repeat it in every slide. So the thing is that when you download some software, like when early today the talk was about the download manager and the way that you can use for downloading software from the SAP SAP market. So the software packages are compressed and are bundled in this file. And SAP provides this program for extracting and handling the information. It's called SAPCAR. Probably most of us know about it. It's a command line program that you can easily use for listing files, extracting, creating new archive files, and things like that. It's available on multiple platforms in all that SAP supports, and works with 3 different versions of the archive files. The latest versions, I think, is worth releasing in March last year. And in that place is the link for downloading it. The program is pretty easy to use. It's like any other extracting archive program. There's a bunch of different commands that you can use for creating new files, for listing the content, verifying, etc. So it's nothing really particular, and it's really similar to any other archive program that you can find. So let's go to the archival formats. For software packaging and distribution, there are 3 different versions. The CAR, which is the oldest version of this type of files, and then they have 2 different that are a little bit new. And well, obviously, as I mentioned, the transport management system in SAP uses also some file formats that are close to the ones in the archive side. So when you use the transport management system that SAP has for transporting objects from one system to another, for example, from a development sandbox to a QA environment, or from QA to production, the information, the objects in SAP, inside SAP, are like bundled and compressed in a particular file format that is put on the transport directory, and from that transport directory, the target systems loads the information and imported it in the target SAP system. So the format is it shares the same compression algorithm and some of the same principles of the archive files. The talk is not focused on the transport files, but most on the software packaging and distribution stuff. So the Caracal format is the old one. I think that it's probably the first that they use. I think that it's really old. It's basically based on two parts. The first is an archive header that is full text based, which is something kind of weird. And there's the blob with all the compressed information itself. So this format is still supporting SAPCAR in this program for extracting files. So you can use it for extracting files that are like 20 years old or something like that. But you can't use a new version of SAPCAR for creating new archives using this particular format. So at some point it's kind of deprecated, but you can still use it for extracting information. The header is basically that way. It has first this kind of 8 catcher that they uses. As I said, it's all text-based, so if you open a file with any binary reader or something like that, you will see that there's a header that starts with this string, and there's a bunch of lines, all terminated by new lines characters. So the idea is that if you go and open these kind of files and read it, the header part, you will find one entry, one line for one of the files that is inside this archive. And each line contains this information, basically the type of the file, if it's a file or directory or something like that, the file name, the permission modes, the modes that the permissions that the file has in the file system, the size, the compressed size, a particular timestamp that is used for like setting the creation of the date creation of the file after extracting it. And finally, a checksum that is an implementation of CRC32. So if you open this file, you will find this header with one entry for one of the files that is inside the archive. And at the end, what you will find is the compression header, which are the 8 bytes that I mentioned, and the blobs for each of the files. So each of the files that are in the header are like put one after the other in the same order. So if you want to read this file, it's just a matter of reading first the archive header and then skipping to the file that you want to extract it, and that's it. And you have all the information that you need. Well, as I said, this is the 8 bytes field and then the compressed blob with all the information. This is an example file, which is a very small one, but basically you can see on the top that it's a valid file that you can extract using the SAP program. And then all this part up to here is the header with the information about the file. And then there's the compressed blob. So if you read all the different files, you will be able to extract this information that is inside the archive file. So going with the another, which is a little bit newer file version, is the 2.00. This version, I think, was implemented in R3 or new versions after 4.7. And in this case, it's binary-based. I mean, there's no text-based header or something like that. All the information in the file is binary. Obviously, it's still support in the SAP card for extracting, but you can't also create new files using this format. So in this case, there's a first header that is on the top of the file, and it's only 8 bytes, but it has a age catcher and the version. This is the only part that is text-based, but it says car, there's a white space, and there's the version number. So when the program opens a file, it reads this information to know which version is the file, and then handle it accordingly to the version. So this is something really straightforward and really easy. The file then is constructed by a list of archive file headers. So instead of the other file format that has one header with all the files, this has one particular header for each file that is inside the archive. And in this case, there are more information there. There's a file tab which is 2 bytes, and it says if the following file is an actual, a regular file, or if it's a directory. Then the permission mode, like in Unix octal encoding. There's the file length. There are some fields that are unknown for me and are mostly not used in the binaries, so I don't know what's the particular purpose. There's the timestamp, which is the timestamp that the program uses for setting the creation date of the extracted files. And then there are more bytes that are unknown. After that, there's the file name. I mean, you have to have the information about the name of the file, of each of the files that are inside this archive. So there's a field of 2 bytes that has like the length of the file name. Then there's the file name, which is a variable string. And after that, it starts like the information that contains the compressed data. There's something that is always fixed on this value, on ED, which are 2 bytes. There's the compression length then, and then the compression header, which is the 8 bytes thing, and the compression blob. All the compressed information is in this particular place. And finally, at the end of each archive, or of each file inside the archive, there's the checksum, which is an implementation of CRC32 also in the same way that for the other file format. So this is, again, a different example with this particular file format. In this case is, well, you will find here the file header with the version and which type of file it's. Then from here to the end, it's like all the information about one particular file, which is this one, this string. You will find the header here from here to the end of that place, and then there's the compression header with the magic bytes and all the compressed data. So this is just for reference if anyone wants to look into the details of the file formats. You will have all the information there. So there's a new version, which is like a small iteration of the previous one. I didn't find any significant change, only that by default they changed the way that the file names are handled. And in this case, no matter what file length you use, the string should be null terminated. At least that's the way that the program uses by default. So the file name, so this part is the same except for the version number. This part is also the same, similar to the previous one, but in this case, this string is null terminated. So that's the only thing that I found that was actually changing the behavior of the programming when extracting data from these files. So having said that, there's an example which in this case is similar, completely similar to the previous one, but it has a null byte here after the file name, and obviously that changes the length of the file name also, because it adds 1 byte. Okay, so let's go to the juicy part and the interesting part. One of the main things that you want to take a look when you review some program for extracting files is how they handle relative and absolute paths. This is something that it's really tied to the way that the program has to extract the informations and read those files into the file system. So something that you will notice if you run the help on the SAP program is this notice that it says that absolute paths are completely applied when extracting files. So this is something to take in mind for some slide after that. Another interesting thing that I found, and I just put it this for fun and for reference, is that when I start looking at the SAP and how they treated files, I found that it opens a file in the same directory that you are. It reads it, and I don't know what it does. I think that for the name, I think that it's something related to the encoding, because the encoding tables in SAP has a similar name, but I don't know why. But the interesting thing is that I can use it for printing ASCII stuff, like for example, the TR from troopers. So this is something really weird. If you write a file in the same directory that the SAP car is running, it opens it and reads it and parses some data, and if the parsing is not the right one, it prints some errors. So this is just for reference. So, okay, again. Oh. It crashed again? Nah. Yeah. Yeah. Okay. It crashed. Might happen. Okay. I'm almost there. Okay, so another thing that is really interesting regarding this, and it was also mentioned on the talk today, is that SAP provides a way to validate that these files are authentic. So they implemented this feature some time ago. The first SAP note that I found was for 2000. Well, these two nodes, I don't know the difference, but it only changes once, one uppercase. But there are basically two SAP nodes that says almost the same. So the SAP CAR program has the ability to validate signatures since this version. There's a new node released this year that documents all the process of validating the signature. So this is the more important part if you want to have a more understanding about how this works. The interesting thing is that the cryptographic primitives that the SAP CAR program uses for validating the signature are provided by the crypto library, by the standard crypto library. So you have to download a version of SAP CAR that supports signatures, and you also have to download the SAP CryptoLib or the new version, which is the common CryptoLib. So you provide the SAP CAR program with the library of the SAP CryptoLib, and it validates the signature. The implementation of the signature scheme is basically based on manifest files. Inside one signed archive file, there's a special file which is called manifest.smf. So this scheme is called detached manifest file because it's just another regular file inside the archive. There's nothing different from a file format perspective. There's nothing different. There's any flag inside any header that says that the file is signed or anything like that. It's just that it has one additional file. This file contains the hashes of all the files that are included in this archive and contains a signature. The algorithms that they use are pretty standard. They use SHA-256 for hashes, and they use PKCS7 for the signature. So they are very well-known primitives for doing signature checks and things like that. Another interesting thing is that the crypto library, this scheme uses public and private cryptographic keys. So you need to have a way to check that the signed file was signed with a valid certificate. So what they did is they embed the public keys of their signing PKA infrastructure into the crypto library. So the crypto library has some hard-coded inside the library, has the public keys for the CAs for checking these files. Another interesting thing is that it supports CRL, which is a mechanism for checking that the certificate that was used to sign one file was not revoked. So you can do like revocation checking within the SAP CAR, which is something really good. If at some point one SAP certificate for signing files gets compromised, they can publish a list saying that that particular certificate is no longer valid, and the clients checking the authenticity of those files will at some point reject and say that that file was signed using a revoked certificate. So that's a feature that is really important and is really good to have in this tool. So this is an example of a signature scheme. Again, this is a regular file that is inside the archive file compressed within the other files. And what you have is a kind of header with all the information of the algorithms that they use, the version of the manifest scheme, and then there's a list of the files that are inside the archive, and for each one they put the hash, which is according to the algorithm that is specified in the header. They put the length of the field name, the file name, and then they put the file name. After the list of all the files, then it starts the signature itself, which is basically using the algorithm that is specified in the header. In this case, it's PKCS7 with timestamp, which at some point provides validation over when the file was signed. So you can check that the file was signed by someone from SAP, but also you can check when it was signed. So you can, for example, find things that might go wrong if the file has a new date, for example, that the one that was used for signing. So this is like the general signature scheme. I didn't take a look into the cryptographic details of it. I'm not a cryptographer, but it will be a really interesting target for some research. This is an example of checking a valid file, and the output is basically that, well, as I said, you provide the crypto library to the SAP card program. You specify using this flag that you want the signature to be checked, and it provides like information about which CA was the one that signed that particular file. So this is the output that you should expect for archive files downloaded from the SAP marketplace, for example. And if you provide like a tampered version of the same file, which has some information it didn't modified, it will say that either that, I mean, if you tamper with the signature, if you modify something without updating the signature, it will say that the file is not digitally signed. And if you remove the manifest from the file, it would say that actually the file was not found and it's not possible to validate it. So these are the indications that the file that you are being checking is not actually authentic, and there are some modifications that happen in some time. Okay, so having said that, and after showing the details about the different file formats, let's go to the attack ciphers. This is the most important thing, because I was thinking about, I was talking about how the files are constructed and how you can handle it, but it's also interesting to think about how a security researcher can attack this and look for vulnerabilities. So, for example, something that is really important in the attack surface of these archive files and the programs that handle them is the compression algorithm. If we've found something in the compression algorithms, we will be able, for example, to compromise the user extracting files with these programs, or, for example, compromising the transport management system or any other system that automatically extracts files from these archives. Another thing that is interesting is to look at the way that the programs handles the archive files. I mean, all these headers and all these fields and the length fields and all the things that references information about the files itself are really interesting for, like, for example, fuzzing them or having a look at how the programs handles that information and how they read it and how they parse all these headers and all the data. Obviously, as I mentioned, something that is really in the attack surface is the signature validation. If we found a way to bypass the signature validation, that would be something really interesting for an attacker, because she will have the chance to provide SAP customers to files that seem to be validly signed, but can contain malicious content or can be tampered with specific things. So that's something really interesting. Another portion of the attack surface is the download process, is what the user uses for downloading these files. This is also something that is really important and is within the attack surface of all this topic. So regarding the archive file handling, well, as I said, there are some special fields that are really interesting. Mostly the way that they handle the file name, which is, this is interesting because it's a variable size string. It's something that you can use, for example, to say that the file name has a particular length, but then provide another different one. And obviously all the metadata that is in the headers and in all the different files. And if you go that way, you will be looking mostly for these kind of things. O sea, something that you can provide to the subcar program and make the program crash and provide some output. In this case, something that is interesting is that this attack path will only provide you of ways to, for example, exploit issues locally, because users will be checking or downloading and extracting files from SAP car archives locally, and you are tied to the permissions that the user has in his own system. But it's an interesting target. And obviously the old formats are the most interesting ones looking at as attack vectors, because there's code that has so many years and was not changed in the last versions. So this is something that is of special interest if someone wants to go in that direction. So another interesting thing is to take a look at the compression algorithm. The compression algorithm is a really really complex piece of code. The code is kind of small. It's only 9 files, and it's almost 3,000 lines of code, which is not that much for something like the numbers that Andreas said today that SAP has. But the thing is that this particular piece of code is shared in a lot of different products and a lot of different components. So every time that they want to compress something, they use this same implementation. So for example, the SAP content server, which is like a web server that you can use for storing documents and things like that, using this for the storage of information, the ABAP code that is stored in SAP database is compressed using this same algorithm. The Diagram RFC protocols uses also this. HANA, MaxiB, well, the SAPcar, which is what we're talking about, the SAPGI. There are a lot of different components and programs that uses the same implementation of these algorithms. So if you find something there, you will probably have a lot of different attack vectors that you can exploit. So this is something that is really interesting and was like the main thing that I started looking at. So, well, actually last year there were 2 vulnerabilities affecting this compression algorithm that were released in May. The first is something that is an out-of-band read when the program, the algorithm, the implementation of the algorithm is decompressing data. So they basically are indexing an array that is non-initialized or properly initialized, and they use some inputs or some things in the input to decide whether they will take some paths or not that at some point end up triggering this. So this is like the guilty line of code, but basically this is something that you can trigger and perform a denial service issue. And again, this problem, you can be able to trigger it in the subcar locally, but also remotely using the protocols, or for example, modifying some data in the SAP database, and every time the SAP system wanted to extract data from this compressed blob, it will be triggered. So this is something really, really interesting. In this particular case, this vulnerability, I don't think that there's a chance to turn this into remote code. So it's only denial of service, but it's a pretty serious one because of the impact. And there's another issue which is quite more interesting. This is when the algorithm for LCZ is decompressing some data. So basically, they put some like macros in the code for checking if there's any overflow, and that should be triggered at some point. But the thing is that these macros were not enabled at compile time. So they are in the source code, but they are not enabled in compile time. And also, if you check out the implementation of the checks, it seems that they are also insufficient. So this particular vulnerability has more impact than the previous one because I think it's likely to achieve remote code execution. And again, this is something that you can use not only using archive files, but also remotely and unauthentically, for example, through the DIAG or RFC protocol, or storing some payload containing compressed information in some places where SAP tried to extract it. So there are some really serious vulnerabilities. They got a lot of attention. I think that this requires some urgent patching. It's been like almost a year, but I still sometimes receive emails from SAP customers that they are just looking at how to patch it, and they should be already patched a lot of time ago. So there are 4 different SAP nodes for some of the different components. In SAPCAR, this is in the kernel. This is for the content server, and there are another one for the SAP-GUI. I think that 4 SAP nodes covers all the different programs. I'm not sure if I'm missing another one, but if you look at it, you will probably find it. So, okay, having explored the attack surface of these kind of files, I think that there's a lot of room still for research and for improvement, like checking out the signatures, checking out the file handle. But it's also interesting to think about the attack vectors. So, okay, let's think that I have a way of modifying an archive file. What can I do as an attacker for having profit of that? This is obviously to learn what, as users, can do to defend. So the attack vectors, some are really obvious. For example, drive-by download or something like that. I put a SAPCAR file somewhere and let the users extract it and at some point achieve something. Obviously, another attack vector is the signature validation. If I have a way to tamper with a file and that file will be still valid, that would be a really nice attack vector. Obviously, anytime that SAP automatically process files that are compressed using this format. Another attack vector would be the download process, for example, using the download manager or just when the user go to the marketplace and download a SAPCAR file. And obviously, all of this is at some point related to the user trust. You want a user to trust that the file that you provided by any means is valid and is authentic. So I will show some examples of attack vectors that, no, it happened again.
Missing license.
Yeah, no, it's not that, because it has, but it's not activated. Okay. Well, we are almost close, so it should work. Okay. That's all.
Already from Microsoft.
Blame them. Okay. Okay, so let's think of an scenario when we want the user to trust that a file that we provide is authentic. We found a way of doing that. Something that is really interesting, and it was mentioned on the talk today also, is that the signature validation is not enforced by default. So you have to explicitly put a flag when you extract the files to check for the signature. And let's also think that absolute and relative paths are supported by default. I mean, you have to explicitly tell the Subcar program that you don't want relative paths or absolute paths. And also, let's say that the installation and the patch procedures that SAP provides in their website and in their documentations recommends extracting SAR files directly in the SAP's directory, for example, in the kernel directory, which is something that actually happens. If you go to some of the installation notes, you will find that within all the explanation and instruction about how to upgrade, for example, a kernel version, they say that you should unpack the new kernel using this command. And this command is running the subcar inside the directory where the old kernel is put. And obviously, this doesn't have the check for the signatures. It doesn't have the flag for checking the signatures. So the general recommendation is do this, and you will be extracting the new kernel and like overreading the files that are there. So if any basis admin will notice that to do that, you will need permissions on the SAP directory. So if you want to run this command, you will need to have a high privileged user on the operating system, which is something that we don't actually want. So I will show a quick demo, but using the library that I have for this thing. What we will do is just opening a SAR file, adding a new file, and using an absolute path, and let's see what happens. So I will do it here. Oh, no. I had that. Okay, so this is like a web-based way of running like Python commands and code. So the idea is that using the library that I implemented for reading this type of files, what we can do is, for example, write a text file that says that this is a new file that we will be using for playing with this. This is just for having a file to write in the demo. Sorry.
I have a quick question about your library. Did you completely re-implement all the algorithms, or are you using the C implementation?
Yeah, that's a good question. The question was if I re-implemented the compression algorithms, and no, I use the C version that is already published from some years ago. In this particular case, I fixed the issues that I mentioned in my code, so that's something important to mention. So basically, in this step, what we are doing is writing a text file, and using the library, we will open something. Oops, I missed one step, which is importing library. So I import the library. I write a text file. Then I create a new archive file using the library. In this case, what I'm doing is creating a new object with this subcar archive. I'm giving a name, saying that I want to write some information. At the beginning, obviously, there's no files inside the archive file. But what we will do is to add a new file. And in this case, this file is now on the archive. We can use like the Python library API for accessing the information inside the archive. So for example, in this case, we will see that there's one file inside the archive. We can access it and check, for example, all the fields that I mentioned that are there in the file, like the name, the size, the permissions that it has, the timestamp, the checksum, check if the checksum is valid, etc. And we can also open it and read information. So this is something, this file is stored, compressed inside the archive file, but the Python API provides a way you to read it and use it like it was any file. So the following step is to write a file and close it, and we can see at the operation system level that the file was written, and you can see that it has the things that I mentioned earlier, like the header and the file name here and all the information. There's the magic byte here telling that the following stream is the compressed blob, and finally the checksum, which are the last 4 bytes. So this is an actual file that was created using the Python library, but you can use it with a valid subcar program. And for example, something that we can do is to open it and try to add a new file. And in this case, what I will do is to add one file, but using a relative part to see how the program handles it. So we open it, added a new file, and wrote it. This is the output of the actual subcar file. In this case, it's not the last version, I think, but it's a new one. And we can see that if you go, we see this is opening the file that we just wrote using the Python library with the actual subcar program. We see that both files are there, and if we want, we can actually extract it, and it was extracted. So this is mostly for like a demonstration of the things that we can do using the library. This is something that using the subcar program you can't do, because the program doesn't have a way for you to specify relative paths, for example, in this way. So this is something that is kind of interesting because it allows a lot of different things. So the following that I want to show is another example when we try to abuse of the download process. Let's say that customers download files from untrusted sources, or they use unencrypted channels like HTTP, in the same way that we saw earlier today, or they put like their archive files inside a share folder that is not well protected, or things like that, or they use the download manager, which has some issues as we saw. So this is a particular case that I was thinking about how to show the impact of these kind of things, and I imagine that let's say that there's a user that wants to download a subnode that has a car file attached to it, and let's say that it accesses it using HTTP. So what we can do is to do a man in the middle in the web connection, in the connection to the HTTP server, using a SSL strip attack, which is a very well-known attack, which is basically changing all the URLs from HTTPS to HTTP and removing all the headers that tells the user's browser to not use HTTPS. So in this particular case, what we can do using the library is to implement this man-in-the-middle attack, and on the fly use the library to infect a sub file with new kind of things, or things that an attacker will be interested on having. So, for example, something that I think it will be interesting is if we know that customers are running subcar with users with high privileges, let's think that one do that using the root user, which is something that I know that it's kind of possible. So what I'm doing here is creating an SSH key, and what I will do in the next step is to run a man-in-the-middle proxy tool, which is called man-in-the-middle proxy. It's a Python. It's a very used in penetration testing and things like that. You can use it for doing a lot of different man-in-the-middle attacks, but some of the interesting thing is that you can write a Python script for doing certain things that you want with the traffic that you are getting. So what I think is that, okay, let's have the user connect to the marketplace and download a SAR file, and we will be infecting it on the fly. So in this case, what we will doing is to put the public key of the SSH key that I recently created, and I specify an absolute path for that file. So let's think that this is running. This is the man-in-the-middle proxy, and let's say that we have a way of performing a man-in-the-middle attack, and let's say that the user access the marketplace via HTTP to not make it difficult for the attacker. But we know that it's something that is quite possible. So I had to put my credentials because it were catch, but I don't know what happens. So let's say that I have there. Okay, so one off. Sorry. So let's say that we log in into the marketplace. Let's say that at some point we perform the actual man-in-the-middle, and we have the user connecting to us by any means. But I need to hit the HTTP version of the node. So I access the SAP node. The proxy is here, making its magic. And I have to provide the password again. So this should work. This is basically, as you say, the URLs in the right are all HTTPS, but the proxy, what it's doing is downgrading everything to plain HTTP, so you can actually continue with the attack. And in this case, I pick a random SAP node that has some subcar file attached, but let's say that the user clicks on it and download it, right? So it's download, it's on the user's directory, but what we can see in the proxy log is that our script was running there, and it downloaded the SAR file before the user get it. It added the file that we say to it to add, and it returned an infected version of the SAR file. So if we can stop, for example, there's no need to stop it, but okay. And something that we can do is, for example, looking at this file and see what we got. So if we look at the file that we just decompress, which is KV file, you will see that the file that we injected is there, and obviously if we extract this, it will overwrite a file that is outside the user's directory. So this is something that at some point it will make users to get compromised, mostly if they are following SAP recommendations of like executing the SAP car in the same folder that the SAP kernel is and running it with high privileges. So this is just for a demo, but you can think of a lot of different attack vectors that might involve this kind of things. It's just a thing of imagination and have different ideas. So as I said earlier, another attack vector is using the SAP Download Manager. In the talk today, we saw that it's vulnerable to man-in-the-middle attacks. So I was curious about if the same might be possible to implement using this. So as you will be able to do a man-in-the-middle attack on the SAP download process. Okay, let's say that we can use the same idea and infect SAR files on the fly when they are being downloaded. So this is something that I was just curious about. I didn't implement it. And finally, I want to have there's some things about the PySAP library. So what I did is I have a Python library for talking using the network protocols, and I extended it also for handling these kind of files. I implemented it for the version 2 and 2.01, not yet for the old versions, and I'm not sure if I will do it. But the idea is that you can do things like this, like opening a file, reading it, and things like that. So just take a look at it, and if you are thinking about implementing attacks like this one that I mentioned, this will be very helpful. So about defense and recommendations, well, obviously ensure that you are running the latest version of everything, like the SAP car, the common crypto library, which in this case, if you are doing signature validation, is a critical portion of that process. Obviously running the latest version of the download manager. Always download software from trusted sources. Use always HTTPS. Protect the share folders or the places where you store these kind of files, the repositories and everything. Always extract files disabling relative paths. This is something that is hard because if you have a file that has a whole structure of directories inside, you will need to extract it in a flat way where all the files will be placed in the same directory, and you have to recreate the structure of them. But there's the only secure or safe way of extracting files without allowing the program to handle relative and absolute paths. And always validate signatures, enable CLR checks, because otherwise you will be checking the signatures but not checking if the certificate that signed this file is still valid. So this is a step that also it's really important. And I think that's it. As a conclusion, what I will have to say is that the life of basis admin is really hard, and there's always new things that you have to take care of, and you have to be very thinking about. Well, there are some new attack vectors that for some might be interesting, for others not, but it's also simply good to have new things to think about. There's more knowledge about the archive files, and obviously there's plenty of further work like fuzzing the files, looking at the signatures, and so on. So I think that's it. I don't know if anyone has another question or something before it crashes again. No, it wasn't before. It's about time.